Good afternoon, all of you.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Today, we are going to solve numericals on the centroid of lines. Before that, you please revise the formulas which you have written yesterday. In the arc of a circle, length of the arc is given by 2r alpha, where alpha is in radians. It is the half the angle made by the arc with respect to the center. If you see the figure, the total angle is 2 alpha. And here this circular arc is symmetrical about x-axis, therefore y bar is 0 and x bar is given by r sin alpha upon alpha. In the numerator, alpha is in degrees, denominator in radians. Please note down this example. A uniform wire is bent into the shape shown in figure. Determine the position coordinates of center of gravity of the bent with respect to point C. So you are asked to find out the position coordinates of center of gravity of the bent. So it is one-dimensional body. So for a one-dimensional body which is made up of homogeneous material, the center of gravity of the body coincides with the centroid of the line. So simply you have to find out the centroid of the given line. Length of this AB is 100 millimeters and there is a semicircular arc of radius 80 millimeters, CD 100 millimeters and DE 150 millimeters. So the first step is you have to select the reference point or reference axis. In this particular problem, reference point is given. So you have to locate the centroid or center of gravity with respect to point C. Second step is you have to divide the given figure, given bent into different parts of standard shape for which you know the position of centroid. So we can divide this bent into a line, straight line AB, semicircular arc BC, line CD and the line DE. Right? And the third step is you have to write the x and the y values of each of these lines. What is x? Distance of centroid of the line from y-axis. Y is distance of centroid from x-axis. Fourth step is you have to find out the moments L into x and L into y. Fifth step is you take the summation Lx, summation Ly and summation L. And the sixth and final step is x bar is given by summation Lx upon summation L, y bar is summation Ly upon summation L. So with respect to point C, I am taking x and y axis, the reference axis. And as I said, we are dividing this into line AB, part 1, part 2, semicircular arc BC, part 3, line CD, part 4, line DE. Now writing x and y, finding Lx, Ly, we will draw a simple table. Line, length of the line in millimeters, x means distance of centroid of the line from y-axis in millimeters, y distance of centroid of that particular line from x-axis in millimeters. N into x, moment of line about y-axis, unit is mm square, and Ly, moment about x-axis in square. Okay. Now say for line AB, length is given 100 millimeters. X means distance of centroid of that line from y-axis. We know that for a straight line, its midpoint is the centroid. So its distance from y-axis is x. Right? It is on the right hand side. So plus 50 millimeters. Now what is y? Distance of centroid from x-axis. So this is y1. Distance of centroid of the line from x-axis. Here is our x-axis. So how much is this? Radius is given 80. So it is the diameter of the semicircle. 160. You can do these calculations afterwards. Then second part is semicircular arc BC. What is the length of the semicircular arc? Pi r. So it is pi into r is 80. Now x. See, this semicircular arc is symmetrical about horizontal axis. I am not saying x-axis. Our x-axis is here, right? So the semicircular arc is symmetrical about horizontal axis. We know that the centroid will be located on the symmetrical axis. Its distance from y-axis is x. Am I right? Distance of centroid from y-axis is x. Now in the formulas, we know that the centroid of the semicircular arc is located on the symmetrical axis. From base, it is located at a distance of 2r by pi. So this distance is 2r by pi. Are you following me? See, if you refer the formulas, we have this as x-axis, y-axis. So it is symmetrical about this vertical axis. Centroid is located over there. From base of the semicircle, it is at a distance 2r by pi on symmetrical axis. So from base of the semicircle at a distance 2r by pi on the symmetrical axis. But it is located on the left hand side. So it is minus. Right? Remember, length of this line cannot be negative. But the position coordinates can be positive or negative depending on the position or location. So here x2 is minus 2r by pi. Minus of 2 into 80 upon pi. Okay. You tell me now what is y? Y2.
80 centimeters.
Right. Distance of centroid from x-axis. So this distance. Nothing but radius. So it is 80. Next, line CD. Straight line CD. we know the length as 100 millimeters, x. The midpoint of line CD is the centroid. Its distance from y-axis is x3. So it is plus 50. And y is distance of centroid from x-axis. It is 0, being it is located on x-axis. Then we have line DE. Length of the line DE is 150. We know that the midpoint of line DE is its centroid. So the distance of centroid of line DE from y-axis is x4. Right? Distance of centroid from y-axis. This is our y-axis. So this total distance is x4. So we have this total 150. Half of that 75. The adjacent side of this rectangle triangle 75 cos 30. Whereas the opposite side 75 sin 30. Now you tell me what is x4?
75 cos 30 plus 100.
Right.
165.
It is 100 plus 75 cos 30. 100 plus 75 cos 30. What is y? Distance of centroid from x-axis
75.
30. Now do the calculation. First multiplication L into x, L into y, then summation. You have summation L, summation Lx, summation Ly. Then x bar is given by summation Lx upon summation L. Y bar is summation Ly upon summation L. While doing calculations, you please take care of this negative sign. Okay. So in calculations, very important. This term Lx will be negative. L into y. This term will be 0. Yes, done with calculations.
Sir,
X bar 36.5 and Y bar 69.4. So you get summation L into X. Two 1942.37. Summation L into Y 41731.4, whereas summation L 601.33. a uniform wire is bent into the shape shown in figure. Determine the position coordinates of center of gravity of the bend with respect to point B. So this bend is in the shape of a number 5. So it is 50 millimeters AB, BC is 50 millimeters, diameter is 100 millimeters. So diameter of this circular arc is 100 millimeters. So you have to find out the position coordinates of center of gravity of the bend with respect to point B. B is one-dimensional body. The center of gravity coincides with the centroid of the line. So with respect to point B, I am taking this positive x-axis and this as positive y-axis. The entire figure is below x-axis. So I am taking this as positive y-axis for my convenience. Then second step, divide this into different parts of standard shape. So we can divide this into 3 parts. Line AB, line BC and circular arc CD. CD is the circular arc. Then you have to take the moments. For that, draw a table. Now roll number 17. Roll number
Yes, sir.
Now tell me, for line AB, what is the length?
80 nanometer. 80 mm.
80.
Yes, sir, it's 80. You've written 50 over there.
In the figure, it is given 80.
Yes, sir, in figure it's 80.
Yes, sir.
Yes, sir. It.
Sorry. Okay. So it is 80 millimeters. X is, what is the value of X?
40.
40 millimeter.
Yeah, if the midpoint is the centroid, so its distance from y-axis is X, that is 40. And Y is distance of centroid from x-axis. It is located on x-axis.
0.
0.
0.
Line BC. What is the length?
50 mm.
50. X.
0.
0. Centroid is located on x. Y is
Minus 20.
25. I am taking this as positive y-axis. Because if the figure is, some portion is above, some portion is below, then you can have plus minus. Being the entire figure is below x-axis, for every part, instead of taking minus, I am taking this as positive x-axis, so that I can use positive sign in the values. Okay. Next, roll number 46.
Yes, sir.
Tell me now, for this circular arc CD, what is the length?
Sir, 100 millimeter.
What is the formula for length of the circular arc? This 100 millimeters is not the length of the circular arc. It is the diameter of this circular arc.
Okay.
Length of the arc is given by 2 r alpha, whereas alpha is in radians. Right? Now you tell me, for this circular arc, what is the value of alpha? What is the value of alpha in degrees? First you tell me in degrees.
135.
So 135 degrees.
135. Very good.
Sorry.
It is 135.
It is 70 by 2 pi.
So two
Sir, 270.
70.
70 na?
Anybody
270.
doubts
Sir,
regarding this?
sir,
130
it
unit is yes.
270 होगा ना?
हाँ sir 270
Double.
270 is the 2 alpha total angle. See, if you refer formulas, we have this circular arc here. It is symmetrical about this
Yes, sir.
axis.
Sir.
So centroid will be located on the symmetrical axis. Its distance from center of the circle is given by r sine alpha upon alpha, right? Whereas what is alpha? This total angle subtended by the r with respect to the center is 2 alpha. Total angle is 2 alpha. Now, in this figure, the ends of this arc are extended on the other side of the center, right? So this is C, D. Then if we join C and D with respect to O, alpha is this total angle. In our case, it is given that this external angle is 45 degrees. So total 180 minus 45. So alpha is 135. So this 45 and this is 45. So 90. So the total internal angle is 270. But half of that, 2 alpha is 270. Alpha is 135. Into pi by 180 radians. 2.356 radians. 2.356. R alpha. R is 50 millimeters, right? And alpha is in radians. So it is 2.356. 2 into 50 into 2.356. Row number 69.
yes sir
Now tell me the value of x. See, this circular arc is symmetrical above horizontal axis.
yes
We know that the centroid will be located on the symmetrical axis. Its distance from center of the circle is given by r sine alpha upon alpha, right? Here r sine alpha upon alpha means distance of centroid from center of the circle. Now here x means distance of centroid of this circular arc from y-axis. So this total distance is x. Now see this right angle triangle.
sir we will add r cos
So add our cos 30.
50. So it is 45. So the adjacent side 50 cos 45, right? And the opposite side 50 sin 45. Now x is equal to, see here, 50 cos 45 plus r sin alpha upon alpha, right? This total distance. So it is 50 cos 45 plus 50 sin 135 upon 2.356. In sin alpha, alpha is in degrees. In the denominator, alpha is in radians. Roll number 72.
Yes, sir.
What is the value of y?
Okay. Y
First, tell me
50
the
50 plus 50
Right.
sine 45.
Correct. So distance of centroid from x-axis. So this total distance. We know that BC is 50 and this remaining distance is 50 sine 45. So it is 50 plus 50 sine 45. Do the calculations. Multiplication, summation, and then division. X bar is equal to summation Lx upon summation L. Y bar summation Ly upon summation.
Bar is 41.2
Sir,
and
41.2.
Y bar is 58.42.
Right. X bar is 41.2 and Y bar is 58.42. A slender homogeneous wire is bent into a shape shown in figure and is suspended from point A. Find the angle made by portion AB with the vertical.
Horizontal.
With the horizontal. Sorry. Is suspended freely from point A. Then you have to find out the angle made by this portion AB with respect to horizontal. See, suppose if it is a complete circle, we are having a complete circle and this AB, when it is suspended from point A, it remains in this position only, in equilibrium, right? But here, this portion is removed. Now, center of gravity of this bend will be shifted towards right or left when this portion is removed?
Left.
Left.
Towards left. But we know that when a body is suspended freely from any point, the center of gravity of the body will be located on the vertical line passing through point of suspension, right? So when you are removing this, the center of gravity will be shifted towards left. But when it is suspended, this point A and this center of gravity must lie on vertical line. Means this bend will swing towards right, so that the center of gravity will come in line with this vertical line passing through point A. Are you getting my point? That means when it is suspended from point A, you will find that this will be the position of the belt. It won't be in this position. So it will tilt. So that when you draw a vertical line passing through point of suspension, the center of gravity of this bend will be located on the vertical line passing through point of suspension. So G is located on this vertical line. Is it clear? Now see, with respect to the center of the circle, suppose if you find out the position of center of gravity, so with respect to point O, you have this as X bar and this will be Y bar. Okay, X bar and y bar, the coordinates of G. Let us say this angle is alpha. You have length of AB is given R, and the radius of this circle is also given R, right? This total is R minus y bar, that is this distance. Now from the right angle triangle AG, and say this is point P. From the right angle triangle AGE, we have tan alpha is equal to opposite side, that is x bar, upon adjacent side, that will be 2r minus y bar. Right? This total up to point O, it is 2r minus y bar. From this we can calculate alpha, and with respect to horizontal you have to find out. With respect to horizontal, let us say theta. Theta is equal to 90 minus alpha. It's simply first you have to find out x bar and y bar for the given bend. You understood this geometry?
Yes, sir.
Yes, sir.
Now with respect to this point O, you find out x bar and y bar by dividing this bend into, for our convenience, it can be divided into three parts. One is this line AB, quarter circular arc BC, and semicircular arc CD. Okay, that is convenient for you. Line AB, quarter circular arc BC, semicircular arc CD. Then find out x bar, y bar in terms of R and put it here, calculate the values.
Sir, please repeat that geometry.
Sorry?
Repeat that geometry.
Yes, sir.
See, when this portion BC is removed, it is known that this bend will swing towards right. Am I right? Because the center of gravity, when this portion is there, the center of gravity of the bend will be located on this vertical line. So when you are removing this portion, center of gravity will be shifted away from the reduction. So it will be shifted towards left. Means for this bend, center of gravity is on the left hand side of this vertical line. That is known to us. But when a body is suspended freely, we know that the center of gravity of that body will be located on the vertical line passing through point of suspension. So it is suspended from this point. This is the vertical line. So the center of gravity of this bend must be located on that vertical line. Okay. So with respect to point O, the position of center of gravity, it is having coordinates x bar and y bar. So x bar and y bar are the position coordinates of G with respect to point O. So using our usual procedure, you can find out the x bar and y bar with respect to point O. Now coming to this figure, x bar means it is the distance from point O along x-axis. This is your x-axis on the left hand side. And y bar is the distance of centroid from x-axis. Okay. Now see this figure. This is AB, and I am joining further from B to E. So this you are getting a complete right angled triangle. So being this is 90 degrees. So if you draw that, you have this is A, G, E, this is 90, and you have GE is nothing but X bar and AE from point A to point O R plus R, it is 2R minus y bar. So it is 2R minus y bar. I am saying this is alpha. So tan alpha is equal to opposite side, that is x bar, upon adjacent side 2R minus y bar. Then you have to find out with respect to horizontal. You have to find out the angle with respect to horizontal. So it is 90 minus alpha will give you the angle theta. You will find the values. Please check. X bar as 0.175 R. And you are going to get y bar 0.087 R. Then you will have angle alpha 5.23 degrees. With respect to horizontal, it is 84.77. This is your answer. So here point to be noted. When a body is suspended freely from any object, the center of gravity of the point will be located on the vertical line passing through point of suspension. Okay. Please complete this sum and we will see in the next class.